Okay, in this chapter, since we're talking about how you relate things in two variables, another way that we could talk about how you relate things in two variables is this idea of what's called a function. Now, before we talk about what exactly a function is, what I do want to talk about just very quickly is something before that, and that's the idea of what's called a relation. So, what a relation is just a way that you represent a set of ordered pairs. Okay? So a relation is just a bunch of sets of ordered pairs. It doesn't matter what they are as long as you have a set of ordered pairs. That would be called a relation. So it can be 1, 1, 2, 2, 3, 3, and that could be all it is, and that is a relation. That's all it has to be. And a more specific type of relation can be something more defined in order for it to be a function. Okay? And what a function is a more defined or more specific relation. It is a relation where, and I'm going to say this two different ways, no x value goes to different y values. Okay? So if something's going to be a function, what that means is just basically no x value can be repeated. All right? And there's a lot of practical examples of what functions are. And the most practical one that we are, since we are in school, the one that I can think of is the fact that you are graded in any class that you're in. So when you think of the grade that you get, you usually get a percent and you get a grade. Now I'm not going to get into pluses or minuses, but if you have a 90 to 100%, you get an A. So whatever you get, whatever percent you get, you're not going to get anything else but that grade. And the same thing is true from 80 to 89. You're going to get a B. And the same thing is true. So if you get a 92%, you only get an A. You're not going to get something completely different. You only get this grade. The only thing you get is that grade. So that is something that defines what a function is. You're not going to get something different for this value. If you use this value, you only get one thing back. So that's what it means for something to be a function. When you plug a number in or when you use one x value, you only get one y value back. And that's the idea of something to be a function. And what we're going to talk about in this section is how you evaluate a function. This idea of evaluate. We've done this before. When you evaluate things, the idea is when you evaluate, you're going to substitute a number for x. But I'm going to put / expression because we might do something else than just plug a number in. And you'll see a little bit later what I mean by that. Okay, so it says evaluate this for x, or when x equals 2. So when you look at this, we have this function, and what a couple things you need to realize is that this is read as f of x. And that's just fancy notation for saying that we have a function. And what this means is that, okay, here's my function. And it says when x is 2. So wherever I see x, I'm going to replace x with 2. So wherever I see this x, it doesn't matter if I see it once, if I see it 3 times, if I see it 10 times. So here I see an x, and here I see an x. So I'm going to replace that x wherever I see it with 2. So if I replace every x that I see with 2, I'm going to replace it, and I'm going to put every x inside of a parentheses. So I replace every x I see with 2. And the reason I put it in parentheses is so that I don't forget orders of operations. Now, you might ask yourself, what do I do with this side of this equation? Well, the answer is nothing, because this is just a way to say what y is. So really the stuff that you have to deal with is over here. So in orders of operations, I got to deal with exponents first. So the squaring of 2 gives you 4, so it's 3 times 4 minus 6, or 12 minus 6. So my answer is 6. So all of this just means that this function at 2 is equal to 6. So the function at 2 is equal to 6. And this is the way you would express that answer. So all I'm doing is just plugging in a number for x. It just looks a little bit different because I'm using new notation. And you'll see later in this book why we use the notation that we do for function notation. You'll see why it's important. It actually comes in handy when we talk about comparing things. But again, looking at something like this, you can see we're given functions. It's different letters, but the exact same thing is going to be true here. Again, this just means P of R. Okay, all that means is that this is what the function is defined as. So what I'm going to do is evaluate when R is equal to -3. So I'm going to plug -3 into this wherever I see it. Now I see R here and here, so I'm going to plug it in 2 different times. But I'm going to use parentheses wherever I see it. So I have orders of operations. I got to deal with exponents first. -3 cubed is going to be a -27. -6 times a -3 is a +18, minus 2. 5 times a -27 is going to be -135, plus 18, minus 2. And if you combine all of those together, you get -119, I believe. So your function at -3 is equal to a -119. So this evaluating is not anything new that you've seen. It's completely the same. It just looks different with notation. Okay? Now, this is where it might look a little bit different. It's asking you to evaluate something with an expression, not a number. Okay? So now, what we're going to see is that your answer that you're going to get is no longer going to be a number answer, but you're going to replace it with a different expression. So what R is going to be replaced with, so here's my function, which is Q of R, and I'm going to replace R with H plus 3. So I need to replace wherever I see R with this h plus 3. So this 2 times r is going to instead be times h plus 3 plus 5. Now you can see here I have still a variable in this, so you might be asking, well, why is this different from what we had before? Well, what we're doing is we're seeing what happens when we change the variable and change it so it looks like a different expression with a different variable. So now we're going to have a different function in terms of a different variable. So I distribute to get rid of the parentheses, so I get 2h plus 6 plus 5. And the only thing else that I can do is combine like terms. These two can combine to be 2h plus 11. My function at h plus 3 is equal to this right here. So we evaluated something. We didn't get a number answer back, but we got a new expression in terms of a different variable. So one thing that I haven't talked about is this idea of range. And it says find the range and domain. Well, the one thing that I haven't talked about is that there are two things that you need to know: the domain and the range. The domain are your x values. The range are your y values. So they give you the domain values. They give you the domain as -2, -1, 0, 1, and 2. Now they're asking you what the range values are. And the way that you find the range values, the y is the same thing as whatever your function value is. So what you need to do is you need to find out what the function is at -2. So you're going to plug -2 into this equation. So -2 squared minus 1. So it's going to be 4 minus 1, which is going to be 3. So I'm going to do the same thing for -1. So I'm just going across here and plugging each number in. -1 squared minus 1, which is 1 minus 1, which is 0. I'm going to plug in 0 now, which is 0 squared minus 1, or 0 minus 1, which is -1. Then I'll plug in 1, which will be 1 squared minus 1, or 1 minus 1, which is 0. And then 2. So I plug in that into the function. So I get 2 squared minus 1, or 4 minus 1, which is 3. So you can see here we have 3 repeated twice and 0 repeated twice, and then a -1. So my range, since we have 5 numbers here, we only have 3 numbers for the range, and the range is just going to be -1, 0, and 3. It doesn't matter which order you put them in, but usually you put them in order from least to greatest, and that's the order that I have them listed here. So this is how you write them in terms of the range. The range is just the y values. The domain are your x values that you see here. And in the second video, we're going to talk about the second part of the functions for this section.